Okay, so let's see. Yeah, that's nice. There we go. All right, there we go. So density and specific gravity. So density we call weight over volume. We got the density of water, 62.4 pounds per cubic foot and 8.34 pounds per gallon. Okay. And what else do we got? We've gone through some examples on this just to kind of get familiar with the basic idea, and then we solved it back for weight, which is density times volume. Okay, so that's some of the stuff we've done here so far. All right, now let's have a look at specific gravity. All right, so with specific gravity, you compare something to the density of a standard. So what you're interested in there is the density of a standard. And typically for liquids, the standard is water. And for gases, the standard is air. All right, and the use of this stuff is, there's like a handbook, probably it's online now, that emergency responders carry with them. And it has the specific gravity of different substances. So if they have a gasoline spill, they're going to see that the specific gravity of gasoline is probably about 0.85 or something like that. So if somebody happens to drive into the canal that goes to the Albany water plant, you all know that canal. It comes off the South San Em, goes through Lebanon, and then through the farm fields and through Albany, and then goes to the plant. Where are you going to worry about that? Gas, because gas has a specific gravity of 0.85. So you're going to put booms on top of the water, or you're going to put something down low to pick it up? What you going to do? Up top, yeah, right, okay. And then if you look at the specific gravity of chlorine gas compared to air, it's about 1 point, I don't know, I really don't know what it is, I don't have that book with me, but 1.5, let's say. Yeah, it's. So if you got a big, I don't know, is anybody here working a plant that has chlorine gas anymore? Okay, big 1-ton cylinders and all that? Yeah.
Big, like 8 of them.
Yeah, okay. So if they were a big problem, and they got a big gas leak and you're in a valley, you want to go uphill or downhill if it's chlorine. You want to go uphill because that stuff seeps down into valleys, right? Okay. So that's one of the uses of specific gravity. It gives you an idea whether a substance is more or less dense than a standard. Okay, so if we've got a substance and it has a specific gravity of 98 pounds per cubic foot, let's see, what that means, okay? So what we would do here, we just divide them out. That's all you got to do, all right? So you just compare your substance to the standard. So I'd look at 98 pounds per cubic foot, and then I'd compare it to water, which, everybody remember that number? Yeah.
4 pounds per cubic foot.
There we go. Yeah, pounds per cubic foot. So that's 62.4. Okay, that's a known value for water. Now notice the units just cancel, and then you'll just do the division and figure that out, and that'll be whatever it is,
1.57.
1.57, okay. And that's a unitless number. It's just a ratio between water and whatever the substance is, okay? So this is just another way of kind of describing the unit weight of whatever substance it is you're looking at, okay? Okay, so that stuff is 1.5 times as heavy as water is. So how about if you got an oil with a specific gravity of 0.929, what would the density of the oil be if you're in pounds per cubic foot? Yeah, about. Everybody, why don't you run that number? You should get to just about 58, just a little bit short of 58.
I got 57.9 for them.
Yeah, that's it. Everyone doing okay with that? Just run it backwards. You're gonna see what you got a substance that is 0.929 times as dense as water is. So you take the density of water and multiply it by 0.929. And if you take it out to 4 places, it's 57.97. Now that will have units, right? Pounds per cubic foot. You could also just say it's 58, you know, it's pretty close. Eh? We okay with that? Okay. So that's just another common way of describing these things. All right. All right, now the next one, we got a few more steps. So let's figure out the volume of this thing. Okay, now what this is, think of this as being a bunch of circles that are stacked, so they're 3 feet high. So to find the volume of that thing, what you're going to want to do first is find the area of a circle. And then you're going to multiply that by the depth of the circle. So what you got here is that the volume is equal to the area. Maybe think of these like poker chips or something. So you got the area, which would be the area of the poker chip, times the depth, how high they're stacked. If you multiply those things together, you get the volume. All right, now be a little careful here. We got 20 inches, but that's not going to mix real well with the feet. So you're going to want to get that converted into feet, I think. You're also given a diameter, and I prefer to use radius because that way I can get the area of the circle, you know, pi r squared and all that, okay? So we're going to have 20 inches over 2. That'll be 10 inches, right? And then get that 10 inches converted into feet. Okay. So just take that 10 inches and do the conversions on it and get the radius, and that'll be in feet now. Yeah, I think so. Got to take it out 3 places just for accuracy's sake. So there we go. Okay, then from there you want the area. That's pi r squared. Okay, so that's why we got that into inches, just so we could, when we get the area, it'll match the depth. Okay. All right. So that's just pi r squared. And I got, what about 2.182? Usually I'll carry 4 places through when I'm doing the math, and then I'll drop it back to 3 when I get the answer, but you know, it's not that huge of a deal, really. Okay. Y'all getting that? Okay. I just multiply that by the 3 feet, that's the depth, and that'll get you the volume. So I got 6.545 cubic feet. Doing all right with that bit? So that's how big the container is. That's how much liquid you could put in the container. All right. So once you find the density and specific gravity, once you've got that. And just kind of keep the units on that and make sure the units are working out, you know, make sure everything fits together. I think this comes out to be 1.49 or something for the specific gravity. I can't remember. Is it or not? Like that. No, I got 2.39, 149 pounds per cubic foot, and then 2.39. Yeah, any liquids that people want. I don't know if I call them. I guess it was. Yeah, or not. It wasn't very tough. You go up there. So you can find the density, just divide the weight into the volume. Then you can find the specific gravity, just divide the density of this stuff and divide that by the density of water. And you'll get that this weighs 2.39 times as much as water does, or has a density 2.39 times as much as water.
2.39?
I'm sorry?
2.39?
Yeah. 2.39. Mm-hmm. You doing all right with that? Okay. Do the next one if you like. Why don't you do that?
Then you just go back to the old page right here.
And then.
Go back to the old original way. I think so.
Get the volume acid.
Yeah.
Yeah, and then just multiply through by the volume. Now you got the volume, you got specific,
Yeah.
you gotta multiply by
There's
60.
like somewhere.
That's for water. You know, it's leave the 1.21 in there.
Oh, and then you have to multiply
Yeah,
by
it's just stuff
water.
heavier than water, water 60.
Okay. Like to write out like all the steps, and you're doing, yeah, you do it like all in one go, so. Yeah, it's amazing. What do you get for that? Wait.
That would get you an area, but you want a radius, 1.5. And then multiply that by the 5
Yeah,
by height.
yeah.
Okay.
It's like 0.1 off the side.
Yeah, right. 25 squared. Or 8. So the way you got. What's that? You got the, then you want the, that's the density, it says Q3, 1.21. Water is that?
This 2006. No, I mean, at the end.
That's just a number.
It says Q3.
What has units is what water has. Water is 60.
Well, that's a specific gravity.
Yeah,
So
right.
if you
One time,
keep
it's like-
I got 0.4 seconds. So just keep 0.4 seconds.
That's the one we found over here. Yeah, that's water. So this takes 62.4, which is water.
Kilogram.
I thought we were supposed to do both of those.
Because the stuff that's in this container is
Specific
1.21
gravity and
times the heavy water.
I did specific gravity.
Is there an error to this?
Times the water.
That one was really easy. It counts as CWU though, I think. One of them. Yeah. Yeah, so let me know why I forget, because I knew that needed an 8.
Now what? Can't do that.
Is it okay if our answers vary slightly because of the?
It's all rounding, no big deal. If you're within like 1% of what I get, that should be fine, okay?
Great chemistry.
What?
That's it.
I like chemistry though.
So getting about 2,670 pounds, something like that?
Yep.
Okay, now you might have something a little higher, a little lower, you know,
I got like
whatever.
266,892, so it's pretty close.
You're gonna build that tank, I think.
Right?
Yeah, you're gonna kind of practice land, you're a little bit off, it's just rounding, it's all it is.
So like, with this, we want to go around our last hole.
Yeah, that would be hard.
And then don't include the, if it's 4 more numbers, don't include the decimal.
Right, yeah, we can just call that. We doing okay with this stuff, everybody doing all right? A little bit there on specific gravity and density.
Way over volume.
Yeah, right. Okay. Now typically, you know, in everyday language, we use the word density for weight over volume. Actually, it's got a little bit different definition, and we don't need to, let's see. You know, we don't need to overkill this, but you do use it in the lab, those of you that are doing the water program. Okay, the English system, we use the weight in pounds, but if you're in the metric system, typically use a mass in kilograms. Weight and mass are kind of similar, but they're slightly different. Okay.
Mass more precise.
I don't know if either one's more precise. Yeah, right. There's this basic physics equation that relates these things together. So force, which is equals mass times acceleration. All right. And what we use is weight, which is a type of force, is mass times the acceleration due to gravity. So mass is how much atomic material is in an object. So a good example of this is if you're here on the Earth. If I'm here on the Earth, I weigh about 180 pounds. Okay. If I go to the moon, my mass will stay the same, but what happens to my weight? Weight down. If you ever seen the film of the first people walking on the moon, they kind of pop because their muscles are built for Earth, but the gravity on the moon is much weaker, so they kind of bounce when they walk. Okay, that's kind of the deal. So their mass didn't change. They still got the same amount of material in their, in their body and all that. It's just their weight does, because the gravitational acceleration goes down on the moon, so they weigh less. Okay. Now we don't need to overkill this. This isn't that big of a deal, but there is a difference between weight and mass. And we tend to use weight in the English system, they use mass more in the metric system. Okay, so if you're in the lab, again, especially for those of you on in the water program, you might start talking about masses or grams of something instead of weight. You might talk about mass in kilograms instead of weight in pounds. You might talk about density in grams per cubic centimeter and stuff like that, okay? So it's just a little different. And so what density actually is mass over volume. That's the technical definition of it. Weight over volume is actually called specific weight. But we still generally use the term density to mean weight over volume. If you're just talking to somebody, that's usually what density means in this country. Okay. Now, let's see. So it's the same sort of thing if you want to find a density. You just find it in kilograms per cubic meter. So for instance, in this example, if you've got the mass and you want the density, you just take the mass this time and divide it by the volume. And just be sure that your units work out. Okay, so we won't go into the difference between mass and weight to that great of a degree. It just has to do with how gravity affects, what weight is how gravity affects a mass, is really what it is. So here, this would be the true definition of density here. It's kilograms per cubic meter. Okay, so if you find the volume and divide that into the mass, you'll get the density. that okay? Good. Yeah.
Up above it says, find the weight in newtons in pounds, 80 kilograms.
Oh,
I was just wondering, I couldn't quite remember the version.
yeah, which, let's see.
It's right before the section we're on now.
Okay. So, find the weight of newtons
Yeah,
in
okay, so
pounds,
I could just
80
connect.
kilograms.
Well, isn't there
Yeah,
kilograms to
yeah, you gotta do a little something with that first. So what you would do, was it, okay, 80, it's 80 kilograms?
Yeah.
Okay, so the way you would do this is you'd use that W equals mg formula, okay? And so the weight is in newtons. So what you do, you'd say W equals the mass, which is 80 kilograms, and you'd multiply that by G in the metric system, which is 9.81. And when you multiply that out, you'll get the weight in newtons, which they don't use a whole lot in the metric system. Now, their scales are in kilograms, if they want to know the weight of something. So the weight there would be 784.8 newtons. Okay, so you take mass, multiply it by gravity, which for the metric system is 9.81, and that will get the weight. Okay. Now, if you got 784.8 newtons, and roughly it's about 4.45, I think, newtons per pound. Is that right? Okay. You could get that converted into pounds. And that comes out to be about 176 pounds. Okay. So that's how you would do that. All right.
So if we do it a completely different way, come up with a number that's about one off, that's okay.
Yep, that's fine. I'll just show your work so I can see what you're up to. Okay. All right. All right, so looks like we're about out of time, but so we'll finish this stuff up on Friday. I'll get that homework assigned. The homework's going to be the 6, 1, 2, 3, 4, and 5, but I'll be getting that on Friday when we finish this chapter up. But the homework will be 6.1, 2, 3, 4, and 5. Now, I've got the Moodle page up now, so I'll post this stuff in Moodle too.